Imagine you order one pizza online. You wait, and after some time, one pizza arrives. Done. That is a future in Dart. Now imagine instead you subscribe to a water pipeline in your home. You open the tap and water keeps flowing. Again and again and again for as long as the connection is alive. That is a stream. In Flutter, a stream is a sequence of asynchronous events delivered over time. Not one value, many values, arriving whenever they are ready. Chat messages, live scores, sensor data, user taps, database updates, all of these are streams. In this video, we will go from zero all the way to a complete working Flutter app powered by streams. Let's dive in. Let's make this crystal clear because everything else builds on it. A future gives you exactly one result in the future, one value or one error, and then it's finished forever. A stream can give you 0, 1, or many results over its lifetime, and it can also emit errors in between without dying. Here is the mental model. A future is a promise of a single delivery. A stream is a subscription to deliveries. And just like a real subscription, you can listen to it, you can pause it, and you can cancel it whenever you want. Keep this picture in your head. One box versus a conveyor belt. Because now we are going to look inside the belt. Every stream, no matter how complex, can only ever send you 3 kinds of events. Number 1, a data event. That is the actual value, like a new chat message. Number 2, an error event. Something went wrong, but here is the key insight. An error does not necessarily kill the stream. It can keep going. And number 3, the done event. This is the stream's way of saying, that's all folks, no more data will ever come. Once you receive done, the stream is closed forever. Data, error, done. 3 events. That is the entire vocabulary of every stream you will ever meet. So how do we actually create a stream? Dart gives us several beautiful ways. The simplest one, Stream.fromIterable. You give it a list like 1, 2, 3, and it emits each element as a data event, then fires done. Perfect for testing. Next, Stream.periodic. You give it a duration, say 1 second, and a function, and it emits a new value every single second forever, like a heartbeat. This one never sends done on its own. It beats until you stop listening. Watch how each one behaves on the timeline, because seeing the timing is what makes streams finally click. Now, the most powerful way to create a stream. Writing your own generator function with async star. You write a normal function, but you mark it with the keywords async star. And instead of return, you use the keyword yield. Every yield pushes one value into the stream. Here is a countdown example. A function that takes a number, loops down from it, waits 1 second using await future.delayed, and then yields the current number. When the function body finishes, the stream automatically sends done. This is the pattern behind real-world streams. You control the timing, the logic, and the values with plain readable Dart code. Here is a secret that confuses many beginners. A stream does nothing until someone listens to it. Creating a stream is just building the pipe. The water starts flowing only when you call the listen method. Listen takes a callback for data and optionally named callbacks, on error for error events, on done for when the stream closes, and cancel on error if you want to stop at the first failure. The moment you call .listen, you receive back a very important object, a StreamSubscription. Hold on to it because that little object is your remote control. And that is exactly what we explore next. The Stream subscription is your remote control over a running stream, and it has 3 magic buttons. Sub.pause. The stream stops delivering events and incoming events wait in a buffer. Sub.resume. The buffered events rush in and delivery continues. And sub.cancel. You hang up the phone. Delivery stops permanently and the stream is told, "Nobody is listening anymore. Clean yourself up." Remember this, because forgetting to call cancel is the #1 cause of memory leaks in Flutter apps. Pause, resume, cancel. You are always in control. Now, an important rule that surprises everyone at least once. By default, a Dart stream is single subscription. It allows exactly 1 listener ever. If a second listener calls listen on it, boom, you get a state error. Why? Because a single subscription stream is like a personal phone call. It is a private conversation. But sometimes you want a radio station. Many listeners hearing the same events at the same time. For that, Dart gives us broadcast streams. You can convert a stream using as broadcast or create one directly. The trade-off? A broadcast stream does not wait for anyone. If no one is listening when an event fires, that event is simply gone. So far, streams created themselves. But in real apps, you usually need manual control. You want to push values into a stream whenever you decide. Meet the StreamController, the single most used stream tool in Flutter. A StreamController has 2 ends: the sync, that is the entrance where you add events, and the stream, the exit where listeners receive them. You call controller.sync.add with the value 5, and 5 flows out to every listener. You call controller.addError and an error event flows out. And when you are finished forever, you call controller.close, which sends the done event. Input on one side, output on the other. This simple object powers state management patterns across the entire Flutter ecosystem. Here is where streams become truly elegant. Because a stream is a flow of data, you can reshape that flow with chainable operators, exactly like you transform a list. .map, transform every value. .where, filter and let only some values pass. .distinct, skip repeated values. .take, accept only the first few events, then automatically close. Watch this pipeline. Numbers flow in, where keeps only the even ones, then map multiplies each survivor by 10. Each operator is a checkpoint on the pipe, and the data that reaches the end is exactly the data you designed. This is functional reactive programming, and you just learned it. There is one more beautiful way to consume a stream, and it reads like plain English. Inside any async function, you can write await for, open parenthesis, final value in stream, close parenthesis, and the loop body runs once for every event in order, waiting patiently between them. It is a for loop stretched across time. When the stream fires done, the loop simply ends and your function continues to the next line. Use listen when you want a remote control. You can pause and cancel. Use await for when you just want to process every event one by one from start to finish. Now let's bring streams into the Flutter user interface with the StreamBuilder widget. StreamBuilder takes 2 things, a stream and a builder function. Every time the stream emits a new event, Flutter calls your builder again and hands you a snapshot, a photograph of the stream's latest state. You check snapshot.connectionState to know if you are waiting or active. You check snapshot.hasError for failures, and snapshot.data holds the freshest value ready to display. Emit an event, the widget rebuilds. Emit again, it rebuilds again. Your UI becomes a living mirror of your data. No set state, no manual wiring. This is Reactive UI, and it is beautiful. Time to assemble everything into one complete real Flutter app, a live tap counter. Here is the architecture. 1. A StreamController of int created inside our state class. 2. A counter variable and a button. Every tap increments the counter and pushes it into the stream with controller.sync.add. 3. A StreamBuilder listens to controller.stream and rebuilds the text on screen with every event. Watch the full journey of a single tap. Finger touches the button. On pressed, fires. Sync.add pushes the value in. It flows through the stream. StreamBuilder receives the snapshot. And the UI updates. Tap, flow, rebuild. That is the entire reactive loop, and you now understand every single piece of it. One final professional habit separates beginners from production developers. Cleanup. A StreamController holds resources, and a forgotten subscription keeps listening even after your widget is gone, silently eating memory and sometimes crashing your app with set state called after dispose. The rule is simple. Whatever you open, you close. In your state class, override the dispose method, and inside it, call controller.close and cancel any subscriptions with subscription.cancel. Do this every single time, and your streams will never haunt you.